quite a lot of risks to think about, vulnerabilities to think about with the cloud. Number one is accountability and data ownership. Who owns the data? Who owns it? So you're using a public cloud, you're hosting your own business services. Whose data is it? So that's number one we want to talk about is a risk with data ownership. User identity federation. So what is user identity federation? Well, the federation is, of course, the Federation of Planets from Star Trek. No, actually not at all. That's what I always think of when I see that term. But what that actually means is I have a single identity. So let's say I log in as Kevin King, and my password is password. Oh man, I should change it eventually, but let's say it's password. And I'm logging in at my local workstation, but using Identity Federation that allows me access to services around the internet and around my organization without having to change my login. Another way to look at Identity Federation is when you are going to a new website, you download the website, and it says log in with your Google account, log in with your Facebook account. That is making use of Identity Federation in the background. We have a single sign-in, SSO, a login, and that is able to be used across multiple locations, infrastructures, and architectures. So if you have multiple user identities for different cloud providers, it's so complex to do so. And so what ends up happening is in order to manage those multiple user identities, we have Identity Federation, and that really helps to manage it better. Now, if you look at the cloud providers, they do a very good job, if you take advantage of it, in helping with Identity Federation and decomplexifying all the different identities that you might end up be needing in a cloud. We also have regulatory compliance. This is a big issue. If you are running a credit card services, or if you are running, working with a hospital or a clinic or something like that, or if you are an organization that is publicly traded and many other things, you need to take the regulatory compliance that you're doing with your on-premise systems and use those in the cloud. And what if the cloud doesn't give you the transparency you need for the different regulations across different countries that you need? The next is business continuity and resiliency. And so if your business has a major risk and that risk gets realized, you can face major monetary loss, especially if the cloud provider handles the entire thing improperly. And so you need to take your business continuity and resiliency plans and work with the cloud provider to make sure that they are going to be able to implement them as your organization requires. The next one is user privacy and secondary usage of data. So a lot of times there are default share features in social media websites. And in that case, you're on the cloud and you post something and maybe you only want certain people to see it, or you don't realize that everyone's going to see it. And boom, you have shared TMI, too much information. Yet another one is service and data integration. So we have unsecured data in transit. So maybe somebody's logging into a cloud resource using HTTP or some other type of unsecured protocol, and people can intercept it and use it for attack. There's also the fact that in your cloud provider, you're not the only one using that cloud service. There are other tenants. And so if there's poor logical segregation between the tenants, there can be one interfering with the other. Not very good. And then we have number 8, which is incident analysis and forensic support. So let's say that there's been a major intrusion into my network. And my forensics team has a method that they go through to track and understand exactly what happened, get the IOCs of that attack and preserve the evidence using the forensic process. But what we've actually recently started using cloud services. But the storage now is distributed across the cloud, And when I go to do my normal RAM dump or use tools in the cloud that I normally use on premise, I can't get the same level of fidelity, the same breadth of information, because the cloud service provider does not work with my forensic analysis process. And so there could be problems with forensic recovery with your CSP, cloud service provider. We also have infrastructure security. What if your CSP misconfigures a section of the cloud? Sort of an example of that is this happened in around 2016 for a cloud service provider in the Northeast. And there was one of their top tier engineers who works for the provider, and he was running a script. The purpose of this script was to reboot servers for a customer. And he ran the script, and it rebooted all of the servers for the entire cloud provider. Can you imagine that? If you are running critical applications in the cloud and all of a sudden your servers reboot, that's insane. It can lead to lawsuits. It can lead to huge losses in terms of money for all of the customers of that cloud service provider. So what ended up happening with, you wonder, okay, I bet you that dude was fired so quickly. But they didn't. They actually didn't fire him. What they did is they asked themselves this question: what kind of company are we that one engineer, any manager, any administrator from one location can run one script and reboot every server? What kind of company are we that can even happen? And so what they did is they used that as a point to review all of their operational procedures, their security, etc. And they kept the engineer. Probably a good engineer, just made a mistake. And I'm glad they kept him because he would have had some trouble getting his next job. So either way, misconfiguration at the service provider can be an issue. Also, non-production environment exposure. So there can be, the non-production environment is your test environment. And the test environment might be exposed, allowing unauthorized access through that environment. Information disclosure, etc. That non-production environment needs to be kept away from exposure to the rest of the world. So there are threats to the cloud because of all these issues that we have in the cloud. There are a huge number of threats. We'll just look at these and stop at a couple of them and talk about them, a few of them. Data loss or breach. This is that you can lose your data because of the way the cloud interface and the cloud resources are configured. Abuse and nefarious use of cloud services. You have an administrator that is using your cloud resources to mine cryptocurrency. Something like that. It's an abuse, right? Or selling storage to someone else and creating accounts for outside users on your cloud. I mean, that's possible. It's an abuse. Insecure interfaces and APIs. You test the API, you find that it allows people to hack into the service. Insufficient due diligence. Your CSP hasn't gone through and checked everything they should, and maybe your organization hasn't. Shared technology issues, because like we said, you're sharing this with some cases millions, in other cases billions of others at the same time. And if you're all sharing the same technology, there could be a problem and you're all potentially affected. And then unknown risk. You don't know every technology that your provider is using. There could be risks that you cannot foresee in cloud computing. Unsynchronized system clocks. So you're running in the cloud, you're using something like Azure Active Directory, and you have on-premise computer systems, and none of them will log into Active Directory because your cloud clocks are different than your on-premise clocks. Inadequate planning and design, conflicts between client hardening procedures in your cloud environment. You try to run the same procedures in the cloud, and there are things missing. A loss of operational security logs. Perhaps they truncate logs automatically after a certain amount, and you can't get them after that. And so therefore you lose visibility to part of those logs. Malicious insiders, that is the same potentially as abuse and nefarious use of cloud services. So somebody on the inside of your organization is doing something they shouldn't be doing with cloud services, or illegal access to cloud systems. The malicious insider, the one who is abusing the services, creates accounts, login accounts for her friends. And so she gives those out, and they log in, and they use those to store their videos and movies and Amazon S3 buckets or whatever. It's not, they shouldn't be doing that. Or maybe they're hacker friends, and they're using the cloud to store items that are illegal, photos that are illegal, things like that. There are many different ways that the cloud can be used. Some of it's illegal. Loss of business reputation due to co-tenant activities. You're on a cloud service provider that provides, that has been the major provider for the crime boss of the Northern Hemisphere. And once it found out that most cloud services are used by the crime boss of the Northern Hemisphere, and you're also using the same cloud provider, maybe the new services will arrive at your door. Hey, XYZ Corp, do you realize that you are on the same cloud as the crime boss of the Northern Hemisphere, right? You can get a bad rep because of someone else who's using the same service. There can be previous escalation, natural disasters. There are always hurricanes hitting in the Gulf, hitting Florida. There are earthquakes in California. There are faults up in Washington, and there are volcanoes all over the planet. And if there is a cloud service provider that happens to fall prey to one of these natural disasters, hey, where's your data? I hope it was on one of the other data centers. Hardware failure in the cloud, supply chain failure in the cloud, traffic, because you're not sure how that traffic is being monitored and managed in the cloud, and so it could be perhaps modified. Isolation failure, someone breaks through your cloud services or their services and breaks into your services. Isolation failure. What if you're using XYZ cloud provider and that cloud provider gets bought by PDQ cloud provider? What happens then? It's been acquired. And the answer is, who knows? There can be management interface compromise for the software that you manage the cloud. There can be network management failure either at the CSP or even in your organization. There can be authentication attacks because maybe when your organization set up the authentication, they used the lowest possible denominator, and now it's being attacked. There could be VM level attacks where either from within the CSP or from within your organization, VMs are being attacked. There can be lock-in. Lock-in. Lock-in is when you are using a CSP, a cloud service provider, and let's say that you have your entire organizational architecture, everything, all your servers, all your workstations, all your let's say your services, like for instance, web services, your databases, your identity services, everything is in the cloud and it's actually going pretty well. Your organization is able to run lean, and then something bad happens around you and you need to cut the amount that you're paying out as an organization every month. And you have this cloud bill. And if you could just move your services from PDQ cloud provider to XYZ cloud provider, you might be able to save $1,000 a month, or maybe even a week or a day, depending on what it is, right? It could be a lot of money. But how do I move all of those complicated services that I currently have in that cloud provider to another cloud provider? It is, in some cases, almost impossible. I will say this, that as time goes on, there are more and more tools to help with this, but you could be locked in. There could be contractual lock-ins where you can't get out of the contract, or for other reasons, technological lock-ins. The opposite of lock-in is when you're kicked out and you can't get into the cloud, but that's a whole other story. We have also licensing issues, loss of governance. Oh, by the way, this happened with Zoom. In early 2020, when everybody started using Zoom, some people realized that Zoom was moving a large amount of its data through Chinese servers. And so since there is no guarantee of anonymity if they're in Chinese servers, essentially you lose governance when that data goes into China. A lot of people figured that out. And so finally Zoom separated those networks and has Zoom for China and Zoom for the rest of the world. A loss of encryption keys is a possibility depending on the types of intrusions or circumstances in the cloud. Risks of change of jurisdiction. I have information in the cloud that originated in the United States but stored in Europe, and there's an investigation. That data, where's the jurisdiction for that, right? Malicious probes are scanned from the cloud or into the cloud provider, and I don't even have access to that. Theft of computer equipment. Somebody breaks into the cloud service provider, steals 17 servers, and guess what? My data is on those 17 servers. It might be backed up, but yet, and I can still access it, but someone has a copy of it. I mean, wow. What about the cloud service terminates or fails, and they terminate me, right? Kick me out of my cloud service. This is all under the auspices. I guess you can put when somebody is deplatformed in number 32 also. You can lose your cloud services. Subpoenas or e-discovery. There could be a subpoena that somehow now encompasses your data, your information in the cloud. Improper handling of data and disposal. So your cloud service provider says, all right, well, we're finished with that server. Let's go ahead and sell it on eBay. And it has your information on it because it was improperly disposed of. A loss or modification of your backup data. So when you go to restore it, it's either not there or half of it's there or it's been changed. That's not very good. We also have compliance risks. Perhaps you signed up with the cloud service provider without doing your research and it turns out they can't handle your compliance issues. You could have economic denial of sustainability. And again, this goes back into the economics of the cloud. We've been talking about that for a while. The security architecture can be messed up. You can have accounts hijacked. So there are lots of threats, and those are 39. And every time I see this list, it grows. And so there's going to be more. So you have to be careful and methodical when planning what you're going to do in the cloud. So one of the cloud attacks that we need to talk about is a side channel attack. Whenever you hear the term side channel attack, that's when you're not directly attacking the service itself. You're going around that and attacking something else that'll give you access to that information. Or sometimes you can call it a cross-guest VM breach. And so what we do in this case is we have an attacker here, a user who's making use of virtual machines, and you have an attacker that's has stolen the credentials of that user, impersonating that user because of stolen cryptographic keys or plain text secrets, stuff like that. So a type of side channel attack can happen when this attacker over here sets up their own VM. And so they're running a virtual machine on the same physical host that the user is. And because they're on the same processor or whatever, they can check that processor cache and use various techniques to steal information from that and use it against it. Because of co-residencies, you can have side channel attack vulnerabilities, a timing attack, data reeminence attack, acoustic cryptanalysis. This is kind of crazy here, where you set up something that listens to what the server is doing, what the acoustic vibrations of that server are, from the fans to the boards in the server, et cetera. There are power monitoring attacks where you look at when power is peaked. So like, for instance, if one of the VMs in that data center or in that particular host does a particular cryptographic calculation, it spikes power. You can look at differential fault analysis and analyze any faults or even create faults and check out the differences between the responses from those faults. So there are lots of attacks that can happen between guests because they're on the same hardware. And you can analyze that, do some cryptanalysis, some other types of analysis, and eventually crack into another VM. Also, we have cloud wrapping. A cloud wrapping attack involves translating SOAP. Now, SOAP is an XML-like communication technology that's used between portions of applications. So in this case, we have a request that's being sent to a web server. It's in the cloud. And then SOAP has a message header and then has a body. And what happens, the attacker intercepts that SOAP message. And then they duplicate that original document, copy the header, modify the body of that, send it back, and then they're able to get various types of information from the application and do other types of attack because of the wrapping attack. Another one is man in the cloud, very similar to man in the middle, man in the browser. In this case, it's man in the cloud. It's a type of man in the middle attack. And so what's going to happen is we're going to start with the attacker tricking their target into installing malicious code. How do you do that? Well, let's say you leave a flash drive in the parking lot. It's 256 gigs. It's brand new. It's in the package. It's never been opened. So they pick it up and they plug it into the computer. Or you get an email message that says, click here to win $1 million. Okay, click. Either way, now that the malicious code is on there, and it plants the attacker's synchronization token on that person's computer, on their disk drive. And so they steal that synchronization token, use that to gain access to their files in the cloud. But guess what? Later, they're going to restore the token with the original synchronized token and return it to the original state. So they can go in and out of that cloud using that stolen token and then restoring it. Very interesting stuff. Next, we have cloud hopper attacks. And so this is triggered at the managed service provider's location. So here we have the MSP. They're providing us with access to services. They control and work with users from many different locations. So we have organization A, organization B, organization C, D. There's organization E right there, and they're the victim. So what's going to happen is this attacker, and the way you can tell that this is an attacker is because of the hoodie. Well, maybe the sunglasses, but yeah, both of those really help. So what they're going to do is they're going to send a spear phishing email that has custom made. So with spear phishing, you're targeting specific individuals. So you know exactly how to make this malware. And so you compromise the staff at the cloud service provider, and you're able to use this to get confidential information and further compromise the cloud services. Another one is called cryptojacking, cloud cryptojacking. And this is where we unauthorizedly, made that word up just now, unauthorizedly use the victim's computer. What are we doing? We are doing crypto mining. So if I have enough computers that are mining Bitcoin or Dogecoin or Ethereum for me, it can be highly lucrative. And so what happens is the attacker can use many different vectors. Like, for instance, there could be a misconfiguration in the cloud itself. There could be a misconfiguration in the way the cloud is implemented locally. There could be websites that are compromised. There can be client-side or server-side vulnerabilities. But either way, the cloud service is now embedded with a crypto mining script, and over time it begins mining and collecting those little pieces of cryptocurrency. The next type of attack is a cloud-borne attack. A cloud-borne attack is an attack that is actually at the bare metal. When we use the term bare metal, we're talking about the actual hardware of the host. What the attacker does is they attack firmware. So there's a backdoor that they inject, then they can exfiltrate customer data through that backdoor. And so they can bypass all the security mechanisms of that server and do almost whatever they want. And so when you think of cloud-borne attacks, that is the bare metal cloud server, the host firmware that's usually attacked to make that happen. Another type of attack can occur using a very interesting tool. This tool is called Lazy, Lazy3, Lazys3. You can call it Lazy3. The S3 is for S3 buckets. So that could be like an E or something like that. So what this is a Ruby tool. In fact, if you start the tool, you can see Ruby, Lazy Ruby HackerOne, and you get it started. So what does it do? It's there to brute force S3 buckets. Remember, we talked about S3 buckets. They are extremely versatile storage. It's an extremely versatile storage architecture for storing lots of information, files, folders, objects through web APIs. And so what they want to do with brute forcing this with Lazy's is they're going to find the bucket's location and name, and then identify vulnerabilities. Another cloud attack tool is Nimbostratus. Nimbostratus is like a cloud layer, right? These are both clouds in the atmosphere. What is the purpose of Nimbostratus? It's to fingerprint and exploit Amazon cloud architectures. Get that IAM, that identity role, extract credentials, metadata, usernames, location, information about businesses and details and so on like that. Nimbostratus does that. But there are other tools that can be used to attack the cloud, including S3 Scanner, CCCat, which is a cloud container attack tool, Paku and Dumpster Diver, and so many others. And this is just a partial list. All right, so now we're going to look at how you can better defend your cloud with countermeasures. Let's put up the countermeasures. So what are some of the countermeasures that we can use to defend the cloud? Number one is enforce data protection. So when we look at what does that mean? To me, I'm translating that as ubiquitous encryption and ubiquitous identity management. So we can protect data through identity management and encryption, making sure we're backing it up, making sure that we have good data retention and rotation mechanisms. Also, read your SLA. What's an SLA? An SLA is a service level agreement. And you need to know what that says for patching, vulnerability, remediation. You need to know what the SLA says for not just those, but for every part of your cloud service with that cloud service provider. Also, make sure that your cloud service provider is regularly undergoing an AAI, CPA, SAS 70 Type 2 audit. So just check with the documentation on that cloud service provider. Check that. Prohibit user credential sharing. So I give the same advice when I'm dealing with, like, for instance, Cisco infrastructure or network infrastructure. Same thing here. You don't want to have like one or two logins and share those things. No, we want to make sure applications, services, and users all have separate credentials. Also, strong authentication, authorization, and accounting. That's AAA. That's part of identity, like I was talking about before. Strong key generation, storage and management. And most cloud service providers have very strong recommendations for this. You may want to follow them. But there's more here. There's also making sure that the cloud undergoes regular security checks and updates. So just like you're going to do in your infrastructure network, you want to always be checking that cloud to make sure that it is ready for attacks. We also want to make sure that the cloud service provider has physical security 24/7, 365. And if you've ever looked at a cloud service provider, you can go to YouTube, for instance, or you can go to a regular Google or DuckDuckGo search and type in a cloud service provider, like, for instance, Amazon AWS physical security. Type that in, and either in YouTube or in a regular web search, you'll find that it's amazing. I mean, they are so physically secure. There's only like one way to get in, and you have to meet a security guard. And if you don't already have an appointment, you can't get in there if you don't have the appropriate physical credentials. And one place I went, not only did I have to give them have an appointment, and I had equipment that I regularly visited in this CSP, but I can't just walk up and go into the provider. And once I give them 2 forms of ID and get into it using a code, etc., in order to get into the physical area where the server surfaces are, there's like a bone geometry scan on your hand, and there are all kinds of cameras, and some places have almost like airport level security. There's a lot of security that you find at these cloud service providers. Look it up one of these days. You'll find it to be very interesting, I think. Also, we want to make sure that we, in terms of security standards for installation and configuration at the CSP and on-premise, we want to enforce those standards. We want to make sure that memory storage and network access is isolated. Again, check with your CSP. Find out what their methodology is for isolation. And better yet, get anecdotal reports from other people who make use of those services and find out if how many isolation failures have been reported for your CSP. Implement a baseline security breach notification process. This is going to be part of your incident handling and response. Analyze API dependency chain software modules, and making sure that you have secure APIs on premise, in the cloud, as a cloud service provider is one of the most important tasks for any organization that deals with applications on a regular basis. There are many methods that you can use to test APIs, including fuzzing and other methods, to make sure they're secure. Right? So very important to do all of this to make sure that your cloud connections are going to be secure. Now, against specific types of attacks, like for instance, a side channel attack, you're going to need virtual firewalls in the cloud to stop one instance from being able to access another instance. We're going to need a random encryption and decryption. We're going to need lockdown of OS images and instances so that there are no vectors that an attacker might follow to attack another instance in the cloud. For wrapping attacks, what we need to do is validate that XML schema to use that validation to detect SOAP messages. Apply unauthenticated encryption in XML, in that XML encryption specification. So we want to make it so that it is impossible for somebody to take advantage of those SOAP messages. For man in the cloud attacks, one of the first things we need to do is have good email security and training our users so that somebody doesn't click on a link and get socially engineered. We need to harden our policies for token expiration so they don't expire so quickly. And also CASB, this Cloud Access Security Border. Implement a Cloud Access Security Border. Why? Because at that cloud border, we want to monitor traffic going to and from the cloud. But what about cloud hopper attacks? Multi-factor authentication. Another thing that we talk about quite a lot is identity management, right? And MFA is extremely important. We want to make sure that we have mutual coordination between the customers and CSP in case you get incidents and activities that seem abnormal. We want to make sure that customers are aware of the cloud service policies. These are very helpful in a cloud hopper. But what about crypto jacking? And one of the first things you want to do is have strong pass-phrases. Have a policy that makes that important for the at the cloud service provider level and at the mainly this is going to be at the customer level that's making use of the cloud services. Always preserve 3 different copies of the data in different places and one copy off-site. All right, so we want to air gap that information. Next, we want to implement coin blocker URL and IP blacklist black holing in the firewall. Blacklist is a list of IP addresses that are known bad. We don't want them to be able to be used anywhere near our network. Black holing is when a a malicious communication tries to make contact with our network, it just gets dropped. And now normally when communication doesn't make it to where it's going, that communication sends back, like for instance, an ICMP message to give the person initiating the communication some type of indication as to what happened, why the communication didn't make it. So I don't care if it's ICMP, I don't care if it's some other type of reporting. With black holding, nothing comes back. And that's really good because then the attacker can't use the feedback information for further attacks. Another one we have is cloud-borne attacks. And to protect against cloud-borne attacks, firmware needs to be on the update schedule. Not just your operating system, not just your applications, but the firmware also. So sanitize server firmware before it's assigned to new customers because it may contain information or and cause more attacks. So these are some of the specific attack countermeasures that we can do. But I want you to know that there are tools that can help with cloud security. Qualys Cloud Platform, a very nice end-to-end security tool to help you to strengthen your cloud security posture. We also have Cloud Passage Halo, another extremely good one. Cypher Cloud, Prisma Cloud, McAfee Vision Cloud, and so many others. And so there's a lot that you can do to secure your cloud. There's a lot that you can do to secure your containers. There's a lot you can do to secure your container automation and orchestration with Kubernetes. And so there's a lot of technology layer upon layer upon layer when you're dealing with the cloud, when you're dealing with containerization, when you're dealing with the specialized attacks that can happen against the cloud infrastructure. We need to be vigilant and we need to map it out carefully and have well thought out and executed policies. So this brings us to the end of the cloud section. In the next section, we're going to spend a little time talking about an exciting topic, and that topic is pen testing. So that brings us to the end of this module, and we'll see you in the next module and in the labs.